Today I am giving presentation on common mistakes observed during civil engineering construction. The entire content is based on my personal experience of 20 years service either as executive or as designer. So, I hope that these issues will be helpful to you during execution of works at site. Coming to the first thing, that is inefficient drainage system, we have seen that this has created problem in the past. So, drainage system of technical area of Air Force Station Gorakhpur, I am referring as an example. What we do, generally we do the drainage system inside our area very beautifully, but we forget to plan the drainage system outside defense land. In every monsoon, there used to be flooding in the runway at Air Force Station Gorakhpur. In case of urgency in 2013-14, dewatering was resorted for 24 hours to drain rainwater from runway and ATC. On either end of runway, there is only private land, no defense land. Then a drain was planned through connected forest to nearby small river which was 2.5 kilometers from defense land. Thus, it is necessary to see that final disposal outside defense land is at lower level and there is no danger of backflow and accumulation of water inside defense land. This is the photograph which I was discussing. Runway is there and this stream is 2.5 kilometers and land is private. So, we cannot go through private land. So, then we went to forest departments and through forest department we got the NOC and then drain was connected and this long problem was solved. Second most important thing in siting is plinth level. Plinth level of each building is very important for local drainage system. Not only natural GL is important, but level of nearby road, railway or any embankment should also be considered while fixing PL of the building. I am giving the example of Army Public School at Kundra Ghat. This building was constructed, but all around there is high level. One side this railway track is going, in front there is national highway and this side there is a road connecting two pockets of army. So, in every monsoon there used to be flooding of water and water even reached up to the classrooms. So, there was one solution which was planned later, a hume pipe connection from school to nearby Ramgarhtal was planned and executed. So, this was the final solution. So, if we take these points in the initial stages, then this after work homework is not required. In case of terrace construction like Naval Academy Ejimala where I was the AG, there is absolutely no problem and on terraces we can have drainage on hillside and then we can cross it through proper planning of drainage system. This is another photograph of Ejimala where terrace construction is there. Now, coming to the second most important thing, that is mistakes observed in soil bearing capacity investigation. Here there is codal provisions, but we have to see the site condition and the call is executives. If terrain is not horizontal, then bore holes must be planned very meticulously. SPT method is sometimes not accurate and refusal encountered may be local, may be dummy. So, bore locks and soil classification is must to know the exact bearing capacity where building is planned. Liquefaction is another important thing where soil loses the capacity to take the load. So, we have to see the codal provisions where liquefaction occurs. Site visit by AG and G during testing of soil bearing capacity is very important. Then afterwards when excavation is done, then also AG and G must see the actual subgrade where building has to come. Mistakes observed in use of basic construction material. This is another important point and I want to bring out that the raw materials water, sand and aggregate are very important. These are not the factory mates, these are coming naturally from the quarries, and the responsibility rests with executives only. In case of other materials where factories or industries are involved, some responsibility is rest with them also, but in case of these raw materials, executives are only responsible. In recent past, department has experienced vast examples of ill effect of poor quality of water, sand and aggregate, which I will be covering in the subsequent slides. Water, salt content particularly in the coastal areas is very important. IS 456-2000 mentions so many criteria to test the water quality. Portability is important thing which is written. In contract, we generally write acidity test, alkalinity test or pH value test, but IS code says so many things. These are mentioned in the slides and you should be aware of all these things so that this ill effect of water can be avoided. Kanasar case is the typical case where building has been vacated, because in Kanasar, which is the Rajasthan area, the groundwater contains salt water in more percentage and it is very dangerous for the building in the long run. In case of fine aggregate, here also we generally take sand from the quarries, and in case of Kanasar there was a quarry from Kolayat where salt content was very high, and if it is not washed properly then it creates dangerous effect for durability of the building. So, these are the tests which are mentioned in IS 383 which we must do very methodologically. Coarse aggregate, deleterious materials same, only range is changed with respect to fine aggregate. Flakiness and elongation index, this new code of 2014 version says combined flakiness index should not be more than 40%. Then mechanical properties limits are also there. Wearing course there is different limit, and for other works there is different limit. Soundness test code also says for fine aggregate what we have to see, for coarse aggregate there is different limits. Alkali aggregate reactions is also very important for durability of the buildings, and there are methods: chemical, mortar bar, accelerated mortar bar, which we must do. Sieve analysis, grading, calibration of sieves, moisture content, strength, abrasion are important properties for coarse aggregate. Coming to other not basic raw materials, but it also does not have much supervision at the workshop, that is the bricks. So, its shape, frog, strength, water absorption and efflorescence are very important. Mistakes observed in RCC work. So, here I want to stress that when a designer starts the design of the building, design starts from roof and it goes towards the foundation, but construction starts from bottom and it goes towards up. So, as per standard practice, designer thinks that the entire framework will be constructed first and then loading will start from top, but practically it does not happen at site because the contractor easiness that progress should be achieved. So, there are methods to achieve this. We can leave a gap below the beam so that it can be filled afterwards. So, if we do not leave this gap and we fill up to the beam bottom and we load the beam at later at stages, then it deflects and it transfers the loads to the wall, which is partition wall and not supposed to take the load. So, cracks appears, and for 2-3 years unless it is stabilized, cracks can be seen. This is another photo. Crumple joint in buildings. This is also very important. We must know the importance of crumple joint, why it is necessary. Just a designer provides the crumple joint because to take the effect of expansion of the building due to temperature and because of variation in the geometry. So, these joints, crumple joints must be very clear. I want to mention case study of MH Bikaner and APS GKP where court of inquiry was ordered because someone came at later stage and said that why crumple is provided in the minor road, but this was the technical requirement and answer was very simple, that we cannot provide, we have avoided the crumple in major OT and we have provided in the minor OT. So, it has to be provided, and you can make this crumple joint watertight or airtight, whatever is your requirement. APS, this Army Public School Sri Ganganagar, I have designed this building, and this building has 13 crumple joints because of its length, because of change in geometry. So, we have to provide this. This was the case in Army Public School Gorakhpur, where crumple was not designed properly and water was coming inside the room. So, then this second B provision was made under maintenance, that instead of 1, 2 joints was kept and the main joint was sealed. Nowadays, these some special companies are coming with mechanical seal. For example, Hercules is coming and giving 5 years warranty for this mechanical seal. So, we must go with these new provisions. This is another diagram of this crumple joint sealing. This is just a calculation, what will be the width of the crumple joint. Cover to reinforcement does not need to be stressed, it is very important for serviceability, durability of the building. Cover in columns, it is the main thing how to do this, but these ready-made covers are now coming, which are having this anchoring device inbuilt in this, so that we can achieve the cover in the vertical surface, columns or retaining walls. Detailing of reverse in RCC members, this is very important. Actually, it is art and not the science. Some tips for detailing of the bars, like this is not correct, this is the correct thing. The pictorial pictures itself is explaining the things. I do not need to repeat in verbal. This is for beam to beam support, there are provisions. This is the correct reinforcement detailing, this is incorrect. In case of staircase, this is the correct provision, this is not the correct provision. So, these you can see and use whenever you are executives, these are the very important. Lapping of bars, the common thing is the 45 LD, 50 LD, generally we provide 50 dia, but mechanical splices are now coming, couplers are coming, which are very useful and generally used in modern industry now. Detailing of construction joint, which is very important, where to leave when day changes or we have to provide the construction joints. So, these I have shown that which is the correct thing, which is incorrect things. The picture itself shows the correct provisions and incorrect provisions. A few cartoons, which this cartoon very beautifully predicts that sometimes we cannot provide longer bars, because then we have to support this, otherwise it will get pre-stressed, and which is not very good thing. Lapped bars sometimes create problem and concrete cannot reach the correct place. Inch water tank, very important, we have to go to the top to see that there is proper cover, because this inch tank or surface, particularly in the conical portion, we must provide proper covers and chairs, otherwise due to insufficient cover it will deteriorate very fast. Chairs, I have shown 2 photographs, this is the correct thing and this is the incorrect things, otherwise the impression will come, you can see the bar when shuttering is removed. Primary and secondary beams, this is very important, sometimes executives do the mistakes and load of primary beam is given to the secondary beams, and result you can imagine. I have seen in one of my site, and there was no provision except to cut the slab and relay the slab. So, generally designer try that depth of primary beam should be more than secondary beam, but if because of architectural point of view both are of same depth, then these provisions must be followed. Upward parapet or fascia, this can be avoided if roof is non-accessible, but if it is required, then it should be monolithic with the RCC slab. If it is not monolithic, it is of brickwork and RCC joint, then there must be proper waterproofing. Shuttering and scaffolding, very important. This has led to many accidents in the past. It has to be designed and its bottom should be hard enough. Its scaffolding should be braced so that there is no local failure. Gaps should be filled, you all know. Now, very beautiful shutterings are coming, specialist shuttering agencies are coming, and we must use these resources. Shuttering alignment is very important, otherwise bulging will be there, how to support the sides. Column, we must restrict the lift otherwise segregation will occur. These are all the photos which shows how to provide the proper alignment, proper straight support for effective shuttering. Cantilever chhajja, reinforcement, this is not correct. These provisions are correct. This is the junction where generally we see the cracks. So, we can end this by say 2-3 inch before, and we can taper this so that cracks are not visible. Case study of wrong curtailment of bars and development length. I was part of a team which went to KV Thane. Now, the KV building which were only 12 to 13 year old, there was problem of development length, and now that building has been vacated, because we found that after 2 stories there is no proper developmental length, and column is not transferring load of top 2 stories to the bottom story, and so many cracks which are not possible to repair we have seen, and now this building has been vacated and new building is going to be constructed. This is due to insufficient cover. Struts bending is very important, particularly for the earthquake criteria. Curing is very important, and there are so many methods are coming in the market, but ponding or curing by sprinkling is still the effective method. Curing compounds, membrane curing, sheet curing are also coming nowadays, provide the curing to the RCC members. These are some of the provisions how to do the curing. These are the important details of 19320 code for the earthquake detailing, how to do the detailing at beam column junction, how to do the detailing as beam column junction at different depth of beams, tie spacing in columns because there are 2 zones near to the supports and midway, and we must follow these criteria. These are very effective, particularly in earthquakes. Wall resting over slab. So, when we are providing wall directly over slab, generally we do not provide wall of full width 230 mm thick over slab, but 115 half wall brick wall is constructed, but this is the correct provision. Where wall has to come, we must provide additional reinforcement as shown in this diagram. This is the outer plinth beam. This is the fin, RCC fin on outside. This is very effective. Water should not go inside, otherwise it will damage. Common mistakes observed in brickwork. Slenderness ratio of wall is very important, which is generally not looked. Frog, hungry joints, staggered vertical joints, top course not touching the beam bottom. Then this code 1905 says that wall should not be slender. Half wall generally after 1.45 meter height is considered as slender. So, we must provide the band, and in the horizontal direction we must provide the vertical bands in case of half wall after 4.3 meter and for full wall almost 9.5 meter. So, these are the codal provisions. If we fail to provide, then cracks are going to come. Common mistakes observed in internal finishes: insufficient hacking of RCC member, thickness of plater should not be more than 15 mm plaster, thickness of plaster is more than 25 mm, then chicken wire mesh must be provided. Slope in flooring is major challenge, at least it should not be reverse slope. This is the hacking is required so that plastering can be effective. Groove in buildings is very important. You cannot avoid this cracks where 2 types of materials, say RCC and wall is there, but having proper provision of grooves, we can hide these cracks. These are the photographs which shows the correct groove and incorrect groove. Electrical conduits which must avoid in case of half brick wall. In case of full brick wall also, conduits should have proper depth from the top surface of the wall, and chicken wire must be provided before plastering. Sunken slabs very important, we must give proper treatment, proper testing and proper arrangement of spouts. The position of spout is very important, otherwise this is the building. I have seen that a lot of water has gone inside the sunken slab and throughout the year it drops. So, you can imagine what will be the condition of the rainfalls inside and what will be the life of the building. Floor conducting and floor chambers to be avoided. In floors we should not provide any service, ELV service, otherwise the water will ingress from anywhere and it will reach to the sunkens everywhere in the building and we will be in problem. The case study of IIT Gandhinagar, where I was there as superintending engineer for 3 years, we have seen this problem and we have done the treatment. So, it needs to be avoided. In case of bathrooms, sometimes in bigger bathrooms it is not possible to provide the proper slope. It is very easy to show the slope direction in the drawings by marking arrows, but since we are using bigger tiles which are rigid, it is sometimes not possible to provide the slope where only one point is given for water disposal. So, the new provisions have come. We have tried at IIT Gandhinagar that these longitudinal drains have been constructed and connected with the chambers, and we have given slope in one direction to catch the water. This is another provision. Common mistakes in external finishes, external grit finish, stone cladding. Stone cladding, I have faced the problem when I was G at Bikaner, and I am showing the case study of MH Bikaner. I was supposed to provide this Dholpur stone in entire surface of 4-story building outside. So, I said to our higher offices that I need to provide the clamps or screws in it, but it was not accepted unless I could show the effect of providing these stones, and stones are falling because of weather change. This is the same building, this MH Bikaner building where I was G. So, these all the points which I have shown, and I will be very happy if any of the tips are useful to you. Thank you very much for your valuable time. Thank you.